We have three problems here from 7.3. We have number 13 is we're going to write sine cubed x as sine only to the power, or sine or cosine only to the power of 1. So if we have sine cubed x, that's like saying sine of x times cosine squared x. Oh, sorry, I'm jumping ahead of myself. Not yet. Times sine squared x. Too eager to get to that cosine, huh? So that's going to be sine of x times, and the power reduction formula says this is going to be a 1 minus cosine of 2x all over 2. So this would be sine of x minus sine of x cosine of 2x all over 2. And that's it. The next one is, that was requested, was number 17. This one's a lot more involved. It's tangent the fourth power of x, or tangent x to the fourth power, times sine of x. So think of this as a tangent squared x times tangent squared x times sine of x. And so just recall that our tangent squared x power reduction formula is going to be a 1 minus cosine of 2x over a 1 plus cosine of 2x. So we're going to have that twice. We're going to have a 1 minus cosine of 2x over a 1 plus cosine of 2x times 1 minus cosine of 2x over 1 plus cosine of 2x times that sine x. And this is going to give us a 1 squared minus 2 cosine of 2x plus cosine squared 2x over 1 squared plus 2 cosine 2x plus cosine squared 2x. Can't forget that times sine x. And then we would have, that's a 1 minus 2 cosine 2x plus, now here's an issue. We have a squared, but we're not supposed to have a squared in the numerator and denominator. So we have to do the conversion again. And so the cosine squared reduction formula is going to be 1 plus cosine of 2x over 2. And we still have this times sine x. Now, I want to clear out those fractions. That's something that doesn't make me happy, having the fractions in there. So I'm going to multiply the numerator and denominator by 2 over 2. And that's going to give me 2 minus 4 cosine of 2x plus 1 plus cosine of, oh, this should be a 4x. It was already a 2x. Let me just clean that up. That's going to be gone, and that's going to be gone. These are 4x's because it's double the angle. The angle was a 2x, it gets doubled. So that's cosine 4x over 2 plus 4 cosine 2x plus 1 plus cosine 4x. And we can't forget our times sine x. This cleans up just a little bit. The 2 and the 1 add up to make a 3. Minus 4 cosine 2x plus cosine 4x over 3 plus 4 cosine 2x plus cosine 4x. So times that sine x. And now we'll just distribute the sine x through the numerator. So it's 3 sine x minus 4 sine x cosine 2x plus cosine, well, I like to write sine first, sine x cosine 4x all over 3 plus 4 cosine 2x plus cosine 4x. And that's it. Okay, the last one that was asked about was number 21. And 21 is a half angle problem. So it's cosine of negative pi over 12. So I like to think of this as cosine of negative pi over 6 over 2 to get to be negative pi over 12. And if you recall, cosine of x over 2 is plus or minus, depending on the quadrant it's going to be in, the square root of 1 plus cosine of x all over 2. Now, one thing to think about in this is the quadrant. Where is negative pi over 12? That's a fourth quadrant where cosine's positive. So we're going to go with the positive part of this. So this cosine of negative pi over 6 over 2 is the square root of, we'll do the positive square root, of 1 plus cosine of negative pi over 6 all over 2. So it's the square root of 1 plus the square root of 3 over 2 over 2. And so here, just to clear out those fractions, I'm going to multiply by 1 in the form of 2 over 2. And we have the square root of 2 plus the square root of 3 over 4. So that could be simplified to be the square root of 2 plus the square root of 3 over the square root of 4. So the square root of 2 plus the square root of 3 over 2. And that's it. Hope that helps.